Great. Hello everyone. This is logic coding. This time we're going to look at another very classical, I think it's elementary dynamic program question called climb stairs. It's very similar to Fibonacci number. We are given n and it asks us to climbing a staircase. It takes n steps to reach to the top. Each time we can either climb 1 or 2 steps. And it asks us to get the number, so it's count. How many distinct ways you can climb into the top. So if we want to go to n, we can reach n from the previous 2 states. One is n minus 1 by climbing 1 step. Or we can reach from n minus 2 by climb 2 steps. So essentially this fn equals to fn minus 1 plus fn minus 2. So the most brutal way is just to use this recursive function, but that would give us exponential complexity. Just like Fibonacci number, we can use a tabular form. We can allocate a DP array to record this. And the time complexity would just be On. And the space complexity, if we do allocate an array, it will also be On. So within that, let's code it up. So the base case will be since I do have n minus 1 or n minus 2, so my n has to be greater or equal than 2. So when n equal to 0, I have one way. And when n equals to 1, I have one way. Otherwise, I can allocate a DP array, which will take n plus 1, and the initialization I can just initialize into 0, and then I can do my dp0 equals to 1, dp1 equals to 1, and when my I starts from 2 plus plus, at the end I just need to return dpn. So the dpi is a function of the previous 2 states. I can just sum them up, I minus 1 plus dpi minus 2. So each I can come from the previous 2 states. One is 1 step before, the other is 2 steps before. If we just sum them up, we are able to get the total ways we can climb to the top. Let's try submit it. So it passes, but as we can see, we can still improve on the space. Why? Because it's only a function of the previous 2 states. So instead of using this DP array, we can just allocate 2 numbers equals to 1 as well. And then at the end, I just need to return B. So in between, I need to, so basically A will equals to B and B will equals to A plus B, which equals to A will equal to B and B will equal to this 10 plus B. And at the end, I can just return B. Let's try and submit it. Cool. So at the end, the space can be optimized just to constant space since we only need 2 variables to store all the intermediate and the final result. That's it for this climbing stairs. It's very similar to Fibonacci number question, and I think it's a great practice for introduction of dynamic programming. Regarding to the state is a function of the previous states. Cool, that's it.